2b. But1e reacts with HBr to produce two structural isomers of bromobutane. 1. Explain which of the two structural isomers is the major product. When HBr reacts with but1e, electrophilic addition reaction takes place. So there is possibility of two products. So one product will be 1 bromobutane. So let me draw but1e here. So we have C double bond C, we have a H, we have a H, we have a H here, and we have C, H, H, and C, H, and H. So if we add HBr, so one possibility is H will go where there are more H according to Markovnikov's rule, and our product will be 2 bromobutane. And if Br will go where there are more hydrogen, then our product will be 1 bromobutane. 1 bromobutane. 2 bromobutane will be major product. Now we need to explain why. Because 2 bromobutane is formed through a secondary carbocation. So secondary carbocation. Secondary carbocation. Secondary carbocation is more stable as compared to primary carbocation. Primary carbocation. And the reason is positive inductive effect of alkyl group. Positive inductive effect of alkyl group. So there are 2 alkyl groups in secondary carbocation, while there's only 1 alkyl group in primary carbocation. So secondary carbocation is more stable as compared to primary carbocation, hence the major product will be 2 bromobutane. Question 2 continued. Explain the mechanism for the formation of major product using curly arrows to represent the movement of electron pairs. So let's start writing but1e. C, 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 and C. First carbon has a double bond and it will have 2 hydrogens. Second carbon will have 1 hydrogen, 2 here, 2, 3, and 1, 4. We have unsymmetrical alkene. Unsymmetrical alkenes, they form 2 products. And in this question, we have been asked to represent the mechanism for the major products. So major product will be through secondary carbocation. So let's write HBr. HBr is a polar molecule. Hydrogen is partial positive, and Br is partial negative because Br is more electronegative as compared to H. So the role of H here is electrophile, and the name of this mechanism is electrophilic addition. Curly arrow shows the movement of electrons. So we have electrons in double bond. So I will start my curly arrow from the double bond to this H. And the bond between H and Br will break. So this is an example of heterolytic bond fission or heterolytic bond cleavage. So as a result, we will have a carbocation formed, and hydrogen will go where there are more hydrogens according to Markovnikov rule, and we will have a secondary carbocation because question says for the major product. So we'll have H here and positive charge on carbon and 2 hydrogen as it is and 3 hydrogen as it is. So this is a secondary carbocation, and plus we will have Br minus with a lone pair. Now the next step is this Br will act as a nucleophile and it will attack the carbon which has a positive charge. So arrow from lone pair to that carbon, and our product will be 2-bromobutane. So 2-bromobutane will be our major product, and CH and H, CH3 as it is. Okay. So that will give us 3 marks here. So I would say 1 mark for the first 2 arrows, carbocation, and arrow will give us the 2nd mark, and the product will give us the 3rd mark. 3. One of the structure isomers can exist as a pair of enantiomers. State the name of an instrument which can distinguish between enantiomers. So we can use polarimeter. Writing polarimeter will give us 1 mark.